Today we're covering the last unit, or the last lesson in the unit, which is day 6, which is the triangle inequality theorem. In years past, we've gotten on Sketchpad. Obviously, we're pushed on time, so I'm going to kind of walk you through it and try and show you some demonstrations as well. First thing we're talking about is the triangle inequality theorem. And let's go down and actually write it in, and I'll go back and show you some of the pieces. It says the sum of any two sides in a triangle is greater than the length of the third side. I'm going to give you a chance to write that down. I'm going to flip back to Math is Fun and show you a quick illustration. So I'm on the Math is Fun website. It says the same triangle inequality theorem, and I'm going to show you right here. They give you the lengths of two of the sides, and we're going to take one of those points. And notice any time when I move this, even if it's obtuse, when I add the two smaller sides, here and here, I get 363, which is greater than 262. Let's go show you another one. If I take it to be an acute triangle, okay, take a look here. When I add the two smaller sides, or any two sides, 165 or 203 and the 146, again, notice that number is 349, which is greater than that third side. And it doesn't matter which sides I pick. So even if I picked 165 and 203, that sum is still greater than 146. Let's go take a look at a right triangle. So if I look here, again, when I add 132 and 203, that sum is 244. Or if I take 244 and add 203, that sum is greater than 132. So any two sides I pick will always be greater than the third side. So back to question 1. Is it possible for the sum of two sides to be equal to the third side? No. Let's take, for example, if I had a 5, 5, and 10. Visualize, if this is my 10, and I link on a 5 here, and a 5 here, there's always going to be an open gap because one of them would have to be longer than that in order to be able to touch and actually form a triangle. So this case would be no. Let's take a look at this one. It says, what if the sum is less than? Well, again, let's try and visualize. If I had a 4, a 3, and a 15. So visualize, here's that 15, here's a length of 4, here's a length of 3. Again, these pieces will never connect, making a triangle. So again, my answer is no. So we filled in greater. Let's go take a look at triangle ABC. It says when I take AB and BC, it has to be larger than the third side, which in this case would be AC. If I take BC and AC, again, it has to be larger than the third side, which in this case is AB. Finally, AC and AB, when I add those two, it has to be greater than that third side, which in this case is BC. Question number 1, can a triangle have sides of lengths 2, 7, and 9? Again, if I add 2 and 7, they're equal to 9, so our answer is no. 2 plus 7 is not greater than 9. Look at the next one, 4, 6, and 9. And if you go through the scenarios, 4 plus 6 would be greater than 9. 4 plus 9 would be greater than 6. 9 plus 6 is greater than 4, so every case works. My answer is yes. You might be asking, do I have to do all that work every time? No, really, you can just take the smaller 2 and make sure it's larger than the third side. Let's go take a look here. We have sides of 3 and 12. We have to figure out what are the possible lengths of the third side. So let's try and visualize. I have a 12. And I have a 3. That means this side over here has got to be at least greater than 9. Not equal to, but greater than. And that third side would have to be less than 15. Because remember, that means I also have to make sure that 3 plus 12 is greater than this number here. So the question is, how are we getting this number and how are we getting this number? Take a look. What are we doing mathematically to get this number and mathematically to get this one? To get this number right here, we're taking the 12 minus the 3. To get this number here, we're taking 12 plus the 3. Moving on to the back side of your notes. The next thing it wanted us to do was measure the angles. And again, for sake of time, I'm going to try and show you an illustration. Okay, the last piece we're looking at is what is relationships between the angles and the sides. We hinted at this with regards to isosceles, but we're going to take it one step further. Let's take a look. We've got A, B, and C. What we're looking at is the relationship between the angle and the side it is across from. So let's take a look in here. When AC is my longest side, take a look at what the largest angle is. It is angle B. And what's the relationship between these two? The relationship is this angle is the cross from this side. Let's take a look at another one. AB is my shortest side, so that would be this case over here. AB is my shortest, the smallest angle is angle C. Now, unfortunately, because I didn't do it on Sketchpad, we can't manipulate it to make it satisfy all of these other pieces, but you might be able to see the basic idea. If two sides of a triangle are not congruent, then the larger angle lies opposite the largest side, or the smallest angle will always lie opposite the smallest side. And again, from a logical standpoint, that should seem to make some sense. So let's take a look at the one example. They've labeled everything. They want us to find the angle opposite each side. The largest side. So for example, angle G, these two go together. G is across from YR. Y is across from that segment there, and R is across from that segment right there. The longest side visibly, you can see right here, is 20, and it is YR, and the opposite angle of that is angle G. The shortest side, if you take a look, is GY, and again, the side of, the angle across from that would be angle R. So from the largest to the smallest, we already figured out the largest angle is angle G. We figured out the smallest angle is angle R, and notice angle Y is the angle in between those, which makes sense because its side is 14, which again is between 12 and 20. So you're going to flip to your homework packet. We're going to go take a look at day 9, and I'm going to walk you through a few examples as well. Okay, so number 1, they want us to figure out whether each set of numbers in a triangle. Remember, we're looking to make sure that every two sides is greater than the third. The easiest case to go look at is adding those two. So I'm checking, is 9 plus 12 greater than 15? It is, so my answer is yes. We look at the next one. We're checking, is 9 plus 10 greater than 20? That is not true, so my answer is no. Okay, moving on to question number 7. It says, between what two numbers must the third side fall? So this is where we're going to write an inequality. And we're going to label that third side to be x. That third side has to be greater than the difference of those numbers. So 15 minus 9 would be 6. And has to be less than the sum of those numbers. So 9 and 15 would give you a sum of 24. largest and the smallest angle. So again, the largest angle is across from the largest side, so that would be angle C, and I'm just going to put largest. They want the smallest angle, that would be across from the smallest side, which is 5. The angle across from that is angle B, so again, we're going to put the smallest. The last one, if you need to, feel free to draw a picture. If you feel like you can do it without, that's okay as well. And I'm going to put AC here first. Let's try, actually, let's go look at BC. I was trying to draw it somewhat to scale. So BC is 21, AC is 18, and AB is 17. They want us to list the angles from the smallest to the largest. So the smallest angle would be across from the smallest side, so that would be angle C. The medium length is 18, the angle across from that is angle B. And finally, the largest side is 21, and the angle across from that is angle A. So tonight's assignment, you're going to finish up day 9 on this triangle